Hi everyone, welcome to CompuScholar's Professional Development Series for February 2019. Today we're going to be talking about flowcharts and how students can use them to help visualize code before they start writing. My name is Chris Yost. I'm the president of CompuScholar. I've spent quite a few years writing software for a variety of large and small firms, so I've got quite a bit of familiarity with the use of flowcharts. I'm also the co-author of many of CompuScholar's courses, so I'm always happy to answer your questions or receive your comments. You're welcome to email me at chris.yost@compuscholar.com. So today is all about flowcharts. We'll begin with a brief introduction and we'll cover some of the basic flowchart symbols. We'll show you a couple of different examples with some basic algorithms and then give you some pointers for further reading. Alright, so basically flowcharts are design tools. These are things that a student or professional might use before they write code in order to help map out exactly what the algorithm or the program is going to do. So this is a great way to visualize this. It's also a great way to help communicate your ideas to others. So you might want to create a flowchart and publish it for review by your teammates or your peers, and this gives everybody a pretty good idea what you're going to do and how you're going to do it before you get started. So you can think of flowcharts as a visual way of writing pseudocode. Flowcharts are essentially composed of a variety of different shapes as well as arrows between those shapes, and you can see a real simple example here on the right. And I want to stress at the beginning that you don't really need to sweat the details or obsess over making these perfect. I have worked in the past with software engineers that would take 20 or 30 minutes at a whiteboard to draw out a syntactically perfect, incredibly detailed flowchart or diagram, and it was really overkill for what we wanted to do, which is communicate ideas and get ourselves on the same page in terms of the design. So just keep in mind that by and large we're working with students here and folks that are not very experienced. So the biggest goal is to help students visualize, to help students communicate, and any type of flowchart that they would like to create that is successful at those goals should be perfectly fine. So let's talk a little bit more about some of the basic symbols in a flowchart. We'll start with the arrows, which I've circled here on the right. So the arrows are flow lines, and these show you how a program moves from step to step. So a program or a thread conceptually is at one particular point on your flowchart at any given time, and the arrows will show you how to transition between them. You'll notice that some of the arrows can be labeled, so the one coming down here from the top is not labeled, but there is some text here on a couple of these others going out. So you can label these arrows in order to show when that particular path is being taken or to give other comments that are appropriate to communicate the ideas. The next basic shape is a rectangle, and a rectangle basically represents some concrete action that a program could take. So it could be as simple as simply updating a variable with a particular value. That's a legitimate action. The rectangles may also represent fairly complex subprocesses. So if you are writing an algorithm to, say, calculate the tax due on a restaurant bill, that's probably not very complicated, and you can do that with very fine-grained actions. But if you're writing a flowchart for something much more complex, like, say, landing a rover on Mars, then you would want to have a flowchart that had many subprocesses, and these rectangles themselves might represent one or more additional flowcharts internally where there's a lot of action going on inside. So you can write flowcharts at a very high level, or you can write very, very detailed low-level flowcharts. The next basic shape is the diamond, and a diamond is used to make decisions. So inside the diamond here, you'll usually write some fragment of a question or a logical condition that you are testing. And then the flow outwards, there's usually multiple flows outwards that are labeled with arrows that have the answer. So if you ask a particular question here and the answer is yes, you'll move over to the right and take a certain action. If you ask that question and the answer is no, then you'll move down and do something else. So typically a diamond will have two different paths coming out, so that is equivalent to an if or an if-else expression, but you may also have additional paths coming out as well, subject to the limitations of what you can diagram, and that might represent a switch statement. Again, we're pretty informal here, so however you want to use your diamonds effectively to communicate the decisions that you're making in your code is perfectly fine. Alright, so let's cover a few different examples, and we're going to start with some general patterns that you might see. The first pattern here is just a sequential pattern. So you see you've got arrows going from step 1 to step 2 to step 3, and there's no decision making involved here. So this is just a sequential algorithm that's going to take a series of steps, and eventually it'll get to the end of the process. So nothing fancy about that. You can also create pretty traditional if or if-else expressions by starting with a diamond. So you'll ask if some condition is true, and if the result is true or yes, then you'll take a certain action here over at step 1. If the answer to your condition is false or no, then you'll come down here and do step 2. That's the equivalent of an else expression. So this entire thing as written is an if-else expression. Now if you just wanted to do an if with no else, then you would draw the arrow from step 1 down and over into the top of step 2, and that represents the if condition just covering the body of step 1, and then whether or not that condition is true, you'll continue on with step 2 in the algorithm afterwards. So there's a couple of different ways you can go there. And then finally you can do loops as well. So this is pretty straightforward. Your loop traditionally at the top will ask, is the loop complete? And if the loop is complete, then it just ends. If the loop is not complete, then it's going to take some sort of steps that are in the body of your loop and then go back to the top and test that loop again. So this might be a for loop or a while loop, for example. So these are just some basic sequences that you'll probably see over and over again as you look through different flowcharts. Alright, let's take a look at a concrete example, and this particular algorithm is going to find the first space character that is located within a string. So we're envisioning a fairly standard string that's composed of an array of characters, and you can access those characters by a numeric index. So the first thing you're going to do as you come in is you're going to take a concrete step here, an action to initialize your index to 0, and then you're going to go into what is basically a loop. You're going to check to see is the character at that index equal to the space that we're looking for, and if the answer is yes, then we're done, and let's just return that index. That's pretty straightforward. But if that character is not a space at that index, we need to increase the index by 1. That's a concrete action. And then we're going to ask another question. Have we run off the end of the string? So is the index greater than or equal to the string length? If the answer there is yes, then we'll have to return -1. That means we didn't find the space at all. And if the answer is no, then we come right back up here basically to the top of our loop, and we check and we see if the new index that we calculated is now pointing at a space character. So this is a pretty easy algorithm, and again, this is not tied to any particular language. This is something that students might want to do to get started before they dive right in and they start struggling with the syntax of a language and where do my semicolons go and how do I actually create a for loop. They can visualize the overall pattern like this before they start writing. So here's a somewhat different example, and in this example we are moving through a list of waypoints. So you can imagine we have this list that has some sort of directional waypoint, and we have an entity, say a robot or a car or something like that, a character that we want to move from point to point. So we'll come into the top of our algorithm here and we'll follow the arrow down. We'll just check our list and see is there anything left. Are we basically done? Are we at the finish line? And if there's nothing left, then we're done. However, assuming there is a waypoint left, we'll get that waypoint, and then we'll look at that waypoint, we'll compare it to, say, our current position, and if we've reached the waypoint, great, let's come up here to the left, that says yes, and we'll check and see if there's another waypoint, and we'll pull that out of the list. So this is a kind of a basic loop here we've got on the left. Now, if you're looking at a waypoint and you're not there yet, then we'll follow no, and we need to calculate what direction do we want to go, or drive, or steer, or step, and then move towards that waypoint. After we're done moving, we're going to reevaluate. Are we there yet? Did we cross the finish line? Did we reach that waypoint? And so we've got another little loop here off to the right where we'll continually calculate direction to the waypoint and take another step and check to see if we made it there. And at some point we will make it to the next waypoint, and we'll branch off to the left here and get the next one. So again, this is very abstract. This could represent an algorithm in any language. And I do want to point out that the way you break down your rectangles into different steps is a bit of an art form, and it depends on the scale of your program and what you need as a programmer. So I chose to calculate the direction to the waypoint and the movement towards the waypoint as 2 different steps. But you could have easily combined these into a single step that said move towards the waypoint, with the direction calculation implied, or you maybe could have broken this into 3 or 4 different steps where the movement perhaps was somewhat complicated and you needed to illustrate a number of different steps to actually complete that movement before you came back and checked the waypoint. So again, the flowcharts are a design tool that are there to help you write effective code. So there's not one right or magic way to do it, that everybody should always do it that way. You should create flowcharts that help you as a student or you as a programmer write more effective code. And so you can do that to whatever level of detail is necessary. So that's really all there is to basic flowcharting. There are certainly many, many more symbols that you could use with additional complexity. If you'd like, you can always get started by doing some quick reading on Wikipedia for a summary of symbols. You can also just use your favorite search engine and type in flowchart symbols or flowchart ideas, and you'll be overwhelmed with many, many results and many resources that explain how to do a variety of things. Now, some of you might be wondering what sort of tools are great for actually creating the flowcharts like the one I've shown. You or your students can certainly use pencil and paper or whiteboard and just sketch them out informally. That's always fine. If you're going to use a software package, that's a nice way to create them for long-term use. So you can use Visio. Microsoft Visio has built-in templates for flowcharts, and there's also many, many other packages that do the same thing. So again, you can search for free flowcharting tools online. You'll find packages that you can download. You'll probably find some things that you can do directly in a web browser as well. So there's quite a few options. The key would be to get something that understands you're actually creating a flowchart and you're not just painting a picture. So if you use a simple paint program, for example, it won't recognize your shapes and allow you to quickly move and edit those shapes and still maintain the concept of the flowchart. So certainly pick a package that understands that you're doing a flowchart and understands what the symbols are and what they mean, and that way you'll be able to quickly and easily edit those things over a longer period of time. But there's a lot of great tools out there, so just do some searching and you'll certainly find something that works for you. I appreciate you watching today. I hope you learned a little bit about flowcharts and are more motivated to use them with your students. If you've got any questions, I'd love to hear them. You're welcome to, again, email me at chris.ust@CompuScholar.com, or you can reach out to us at our website. There's a phone number there, or you can contact us through CompuScholar.com. Thanks for watching.